Okay, welcome to part B of session 2. I'm still talking about comparative advantage. Okay, so I just gave a little anecdote about my wife and I, who's going to do the cooking, who's going to do the dishes, who would have the comparative advantage. I'm going to move to a slightly different topic now. Okay, it involves an old show, actually it might still be on, called Shaq Versus. And Shaq is Shaquille O'Neal, former basketball player. And in this show, what would happen is Shaquille O'Neal is somehow matched up against these sports stars in other sports. And then somehow Shaquille O'Neal is given a head start or some other advantage to make it fair so that he can actually have a somewhat even match after the head start against that other sports star. And so in this one show, Shaquille O'Neal is going to go up against Michael Phelps, and they're going to swim. Okay. So, of course, Michael Phelps is going to be a lot better swimmer than Shaquille O'Neal. So, what they do is they make a special race where I think it was 200 yards. Michael Phelps is going to swim 200 yards, and Shaquille O'Neal gets to be on a relay team where each one of the members of the relay team is going to swim 50 yards. Shaquille O'Neal will be the anchor. He'll swim the last 50 yards. And the other people are going to be these elite, world-class women athletes who, because they get to dive and they're swimming a relay, they're not swimming as far as Michael Phelps. It's going to be approximately a fair event. Okay. So let's use that as an example to think about comparative advantage. Okay, let's make it even simpler. So Katie Ladecky, hopefully we all live in Northern Virginia. Katie Ladecky is probably currently the greatest women swimmer in the world. Let's suppose that Katie Ladecky and Shaquille O'Neal are going to form a medley relay in swimming. Okay, and in this special medley relay, they're only going to do two strokes. One's going to do the freestyle, one's going to do the backstroke. Okay, and the question is, who should do what? Should Shaquille O'Neal do the freestyle, Ladecky do the backstroke, or vice versa? Okay, so let's suppose that here are their capabilities. In any 5-minute interval, okay, let's suppose that Katie Ledecky can swim 10 laps of freestyle, or in that same 5-minute interval, she could swim 5 laps of backstroke. Okay, let's suppose that Shaquille O'Neal in any 5-minute interval could do 3 laps of freestyle or 4 laps of backstroke. Okay. First of all, let's do a warm-up exercise. Who has the absolute advantage? Okay, this should be easy. Katie Ledecky is better in freestyle. She has the absolute advantage in freestyle. She's also better in backstroke. She also has the absolute advantage in backstroke. Okay. Now, the harder question. Who has the comparative advantage in each stroke? Okay. Now, if you paid attention to that last video, it would be easy if they differed who had the absolute advantage. If one had the absolute advantage in free and the other in back, then it's easy to decide who has the comparative advantage. When it's hard is when one of the swimmers has the absolute advantage in both strokes. And that's what we have here. Katie Ledecky has the absolute advantage in both strokes. So it's fairly difficult. Now what we have to do is we look at the worst swimmer. the one who has disadvantage, I gave you that recipe, that's Shaquille O'Neal, and we say, which stroke is he almost as good as Katie Ledecky? Okay. Now, before I just used almost in kind of the way we commonly use almost. But now I want to define almost in a special way. Almost means you do a math problem where you divide. And so what you do is you say, well, in terms of freestyle, the division problem is take Shaq's number of laps in free, divide it by Ladecky's. So 3/10, and then in backstroke, you take Shaq's amount, 4, divide it by Katie Ladecky's amount, 5, 4/5. And you say, which is higher? And the answer is 4/5. Okay, so by this method, when we say almost, we say that Shaq has got to be almost as good in one of them, by the way that we're defining almost, and so you use the higher one. Another way of saying it would be something like if you were to say Shaq was almost as good in either stroke, maybe he's not really almost as good in either stroke, but which stroke would you pick? Which would you have the best ability to say almost and keep a straight face? Okay, and so you would say backstroke. Let's try another warm up. Just suppose instead that these numbers had been 1, and suppose that had been 2. His backstroke had been 2. Okay, so if this were true, in neither stroke would it make sense to say Shaq is almost as good as Ladecky. In both cases, Ladecky is twice as fast as Shaq. But the way I'm defining almost for comparative advantage, we would say which one could we say almost and have the best ability to keep a straight face? Well, what we do is freestyle. We would do a division, 1 divided by 10. For backstroke, we would do another different division, 2 divided by 5. Since 2/5 is bigger than 1/10, here again, we would say in the backstroke that it's easier to keep a straight face and say Shaq is almost as good at backstroke. Okay, so here's the first case. So in this example, we would say Shaquille O'Neal has the comparative advantage in backstroke because that's the one he's almost as good at. Okay, and I told you with comparative advantage, in my class we'll never have ties, so one person will have the comparative advantage in one task, the other person will have the comparative advantage in the other. That will always be the case for the entire course, okay? So, if Shaquille O'Neal has the comparative advantage in backstroke, Katie Ledecky must have the comparative advantage in freestyle. Okay, so we've done the first part of this. Okay, in fact, that's all. That's all I wanted to do. So for this example, we've now explained, we've computed who has the comparative advantage in each. Let me change this problem just to make it slightly different, and I want it to conform like the example that's given in the book. And that's in the example in the book. I'm just going to change some of these terms, and instead, in the book, instead of a swimming example, it was this example of producing these 2 different types of beer. So instead of a 5-minute interval, what it did is it considered a 6-month interval for 2 people. Instead of Katie Ledecky and Shaq, it was Jones and Brown. And let me go back to the original numbers. Instead of the green, we have 3 free, 4 back. Okay, but in this example in the book, instead of talking about swimming strokes, what it talked about was gallons of lager versus gallons of stout. And so it uses the exact same numbers, okay? I chose these numbers on purpose. So what it has is Jones can produce 10 gallons of lager in a 6 months period, or he can produce 5 gallons of stout. In the same way, Brown can produce 3 gallons of lager or 4 gallons of stout. Okay. So let's erase the green. We use the same numbers. So here again. So now we've already computed who has the comparative advantage. The answer is just like we had Shaq. Now we just have Brown. Brown has the comparative advantage in stout because 4/5 is bigger than 3/10. Okay, so here we go. We already have the answer to this. Who has the comparative advantage in stout? Who has the comparative advantage in lager? Brown has the comparative advantage in stout. By the way, freestyle lager. And so Jones has the comparative advantage in lager. Okay. Now, the book, I think, uses a much more complicated method to solve this. It talks about opportunity costs. So Brown's opportunity costs of producing lager, if he produces an extra gallon of lager, how many fewer gallons of stout must he decrease it by? And the book calls that the opportunity cost, goes through the calculations of calculating those opportunities. You use the opportunity cost to decide who has the comparative advantage. I think that method is much more complicated. And I think it's better and easier to remember if you use what I call the almost method. Look at the one who is disadvantaged on each and say which task can we say that person is almost as good as the other one. In this case, we would say Brown's disadvantaged, but he's almost as good at stout to Jones. Okay, so in this case, once again, we would say Brown has a comparative advantage in stout. Jones has a comparative advantage in lager. Okay, next thing. The book talks about something called the production possibilities frontier. Okay, I want to go over that right now. Okay, that's a little tricky. It's a little bit of math. It's really nothing harder than, I'd say, 7th grade math, but you just got to see it a few cases and get some practice to understand. So what it says is, let's talk about, we're just going to concentrate on Jones for the moment. Okay. So Jones can produce so many gallons of lager, or he could produce so many gallons of stout. Okay. Now we're given in the problem that in the 6-month interval, he could produce 10 gallons of lager or 5 gallons of stout. And what it meant to say, he could produce, if he wanted to, 10 gallons of lager and 0 of stout, or he could produce 5 gallons of stout and 0 of lager. Okay, so what that means is that the first statement is that this point here, so if this is 10 and this is 0, so that's a point in the production possibility set. So he can produce 10 gallons of lager, 0 of stout. Another possibility is that he produces 5 gallons of stout and 0 of lager. Okay, so now we have 2 points in the production possibility set. Okay. Now, keep in mind when it says this, when it says in 6 months he could produce 10 gallons of lager, so what that means is if we divide that in half, so if he spent, instead of all of his time producing lager, let's suppose he spent 50% of his time producing lager and 50% of his time producing stout. I'll put that in, I'll use green. If he did that, how many gallons of each? Well, 50% of lager, okay, that means he would cut that in half. So that he could do 5 gallons of lager. If he cut that, if he spent 50% of his time on stout, he would get 50% of that number, which is 2.5. So that's, if instead, so this dot is when he spends 100% of his time on lager, 0% on stout. This is 100% on stout, 0% on lager. I said, what if he spent instead 50% on each? He would produce 5 gallons of lager, 2.5 gallons of stout. And so what that would be is a production possibility of that dot. Okay. Now we could try another case. What if instead, let's do it in red. Let's suppose he spent 20% of his time on lager, 80% on stout. What would he produce? Well, in this case, 20% of lager, that would mean he produced 2 gallons of lager. And so I said 20% of lager, 80% on stout. 80% of 5 is 4. So that means another possibility is 2 on lager and 4 on stout. So this would be another dot on that production possibilities set. Okay, if I kept doing this, kept trying a whole bunch of different percentages, didn't quite draw that green dot right. We should get a straight line. Yeah, I didn't. Pretend that line. It looks pretty curved. I didn't quite do it right. That should have been a straight line. Okay. That says all of those possibilities should lie on that straight line. So if this is 100%, this point's 100% stout, 100% lager, 0% stout. Something right here would be something like 99% lager, not 1% stout, 98% lager, 2% stout, and so on. That's how we would complete that black line. Now, let's be clear. Jones could have spent part of his time doing nothing. So here we said, here's 100% of the time on lager, 0% of the time on stout. What if instead it said, well, I'm going to spend 50% of my time on lager and 0% of my time on stout, and the other 50% of my time just goofing off, doing nothing, just leisure. Well, he would produce 5 gallons of lager, 0 of stout. Okay, so if he starts engaging part of his time on leisure, just goofing off and doing nothing, he can do anything inside this triangle. So we say the production possibility set, all the different amounts of lager and stout that he can produce, is this whole triangle, and we color in the whole triangle. Okay, so this is inside the triangle. The whole triangle is production possibility set, and then the line at the edge of the triangle we call the production possibilities frontier. Okay. All right. So that's just a term I want everyone to understand. Okay. Production possibilities set, production possibilities frontier. Okay. The book does a similar calculation for Brown. This is just for Jones. Okay. I want you to be sure to read the book so you can understand how to do that for Brown. Okay. Next, I want to show the key point. So this is it's almost like a magic trick. We're saying with law of comparative advantage, we're saying here's a way we can make one person better at both goods. So Jones is better. Jones is better at both goods. You'd think they wouldn't want to trade, but I want to do something like a magic trick to say, let's set up a case where they're each on their own. They're each kind of self-sufficient. So Jones is producing his own lager, his own stout. Brown is producing his own lager, his own stout. And let's see, once we get that, is there a way we could change the mix of what they produce, let them trade, and then make them both better off? Okay. And in general, you can always do that. And so if you think of this as a magic trick, I'm the magician, I want to show you what I have up my sleeve. And the answer is I'm going to make both of them spend a little bit more time on the task for which they have a comparative advantage. Once we do that, we let them do that, and then we let them trade, we can make them both better off. Okay, so let me do such a magic trick. Okay, let me just pick a case. Okay, so um, if I did this class in person, I would ask for an assistant and have you pick one point along the production possibility frontier for Jones, one for Brown. Then I'm going to change how they produce and let them trade. Um, I don't have a class in front of me, so I can't pick that. So I'm going to pick something almost at random. I'm going to do is I'm going to say, let's suppose, so case one. This is the original case. Let's say Jones is spending, what do I want to do? Let's make it 40% of his time on lager, 60% of his time on stout. Okay. So if he's done that, that means Jones would produce 40% of lager. That means 4 gallons of lager. And then he's spending 60% of his time on stout. If he spent 100% of his time, he can make 5 gallons. 60% of that is 3. So he's going to make 3 gallons of stout. Okay. So Jones, working alone, no trading. He's on an island, say. Let's say that's what he's making. 4 gallons of lager, 3 of stout. And let's make Brown spend um, make him spend 50% of his time on each. So 50% on lager, that means he will make 1.5 gallons of lager. And 50% of his time on stout, so means he'll make 2 gallons of stout. Okay. So here would be a good test question. It would be a hard test question, but I want you to be able to answer it. Okay, if you want to get 100 on the exam, you're going to have to be able to do something like this. So the question I would ask is something like the following. Suppose here's their production possibilities frontier. Jones can make 10 of lager, 5 of stout, or any linear possibility of those. So a good warm-up question would say draw their production possibilities frontier. So we've already done that. Do something similar for Brown. And then I say, suppose that in one state of the world, Jones is making 4 gallons of lager, 3 of stout, and he's consuming it himself, only what he produces. He's not trading it all with Brown. Meanwhile, Brown is making 1.5 gallons of lager, 2 of stout. Okay. You are the benevolent dictator. Can you specify a new way of producing things, a new set of numbers that they can produce, which are possible? Tell them to produce that new set, that new outcome, and then trade. And trade such that, and then once you specify that, is it possible to make both people better off? Okay, and the answer is you can. You can do that. Okay. Specify the specific way you would do that. Okay. Now there's lots of ways you can do that, and I'm going to give you one. I'm going to give you one answer that would be 100% correct on the exam. Okay. Like I said, the magic trick, what's up the sleeves of the magician, is to make both of them spend more time on what they have the comparative advantage on. So remember, Jones has the comparative advantage at lager. Brown has the comparative advantage at stout. Okay, so you got to make Brown produce more stout, less lager. Jones the opposite. Okay, that's the key. Okay, Not only that, okay, once you know that trick, it's just a matter of experimenting with different ways, and you can usually find something. It's even easier if you can remember